So in the previous class, we have seen XPath. So how we can locate elements using XPath. So different XPath, absolute XPath, relative XPath. And again, by using relative XPath, we can have different type of functions we can use instead relative XPaths. Right. So this is XPath access. So this is a little advanced concepts of XPath. So in the relative XPath itself, so we can also use something called XPath access. So basically, what is an XPath access? So let me show you a scenario when exactly we use XPath access and why we need to use. So sometimes if you are working with some complex applications, you may not find some attribute for the element. Let's say if you want to locate some web element and you don't have any attributes for those elements, but still we can find that element by using a neighboring elements. So if you have any element neighboring, so by using that element, you can access that. So for example, let's say, so this is one element you have. So to locate this particular element, especially, you don't have any attributes to locate this element. So in this case, what you can do, you can take some neighbor elements, any element, and by first we will identify this neighbor element, and by taking the help of that neighbor element, you can find the actual element. So in that case, we can use this particular XPath access. Okay. So the element can be some parent element, or the element can be a sibling, or element can be child element, or element can be following element. So there are different type of element. We can call them as different names. They're all neighboring elements. Okay. So axis is nothing but what? By using XPath axis, we can navigate from top to bottom, bottom to top. So normally, so nodes will be aligned like this in the hierarchy mode, right? So if I use CSS, for example, this will traverse only top to bottom, and we cannot go to reverse direction. But in XPath, we can also, by using especially XPath access, we can navigate to any direction. So we can navigate from top to bottom, or we can go to bottom to top. For example, let's say I want to locate this element, for example, but I don't have any attribute for this element. Then I can locate this element first. And once you located this element, based on that, you can navigate the previous element or the parent element. So this is top down, up, bottom to top. So XPath access, in all directions, we can navigate and we can locate the web element. So for that, we have different options are provided. Like self is nothing but the node itself is called a self. And we have a parent, we have a child option, ancestor, descendant, following, preceding, again following sibling, preceding sibling. So there are multiple options are available in relative XPath. So by using those options, we can traverse throughout the DOM, and wherever the element is available, you can find that element. Okay. So the main purpose of using XPath access is, if I don't have any attributes for the element, still we can locate this element by using any other neighbor element. Okay, any other neighbor element. Okay, this is simple XPath access concept. So we'll see how we can use these options and locate the web elements. So self is the node itself. We can call as a self. So whichever node we are trying to identify, that node itself is called as a self. Okay, and self node, we no need to use self keyword especially, because the node itself is we can locate the element by itself, which is called as a self. Okay, and rest of the things are important. So parent, so whichever axis we are going to use here, all the things we can use it from the self node itself. From where we have to start. So first we need to identify that from which node you want to locate parent, or from which node you have to locate the child. So that is self node. From the self node, we can locate all other nodes or all other elements. Okay, so first let us start with one by one. So we'll understand what are this terminology, and then we'll see how we can use them practically. So to understand this, I'll explain this with a picture so that you can have more clarity on this. Let us see this. So whichever node is whichever node is highlighted with the red, which is self node, we are starting with them, and green color is identified nodes. So whatever nodes or elements we are trying to identify, so those are the elements which is represented with the green color. Okay, now look at this. What is parent? Very straightforward. Let's say y2. This is my self node, for example. For this y2, what is a parent node? B2 is a parent node. So normally if I look at the DOM looks like this in the hierarchy mode. All the elements are aligned in the hierarchy mode. So XPath works based on the DOM itself. So for example, if you want to locate this B2. So what is this B2? B2 is a parent of Y2. So the parent option we can use to locate the parent element. But here, what is the target element we want to locate is B2. But we are not writing XPath directly for B2. We will write XPath for Y2. From there, we can use parent option to locate B2 element. Okay. And what are other, okay, so for Y2, B2 itself is a parent element. For Y1 also, B2 is a parent. For Y3 also, B2 itself is a parent. Okay. And here you can like say X1, X2, X3. For these three elements, B1 is a parent. And again, Z1 and Z2. For these two elements, B3 is a parent. So parent is a straightforward. So if I look at any element, we can easily identify the parent element. That is a parent. Now, next one, child element. Parent and child element. So what is a child element again? Child. So what is a child? So if I look at the B2 is my self element. Y1, Y2, Y3 are the child elements of B2. Y1, Y2, Y3 are the, because these are the three elements directly created inside the B2. So Y1, Y2, Y3 are the child elements of B2. Similarly here, X1, X2, X3 are these three are the child elements of the B1. And here Z1 and Z2 are the child elements of B3. So this is parent and child relationship. Okay. For Y1, B2 is a parent. For Y2, B2 is a parent. For Y3 also, B2 is a parent. Similarly, for B2, Y1, Y2, Y3 are the child. For B1, X1, X2, X3 are the child. For B3, Z1 and Z2 are the child elements. So to locate these child elements from the parent element, we can easily do that. Suppose if you do not have any attribute for any child elements, now I still want to locate these elements. You can still locate them by using parent element. So first we locate B2. From there, we can navigate to the child element using child option. So this is a one option, parent and child. So next one, ancestor. So ancestor is nothing but from the parent, all other above elements will come into picture. So let's say this is my actual self element. So B2 is a parent, parent of parent. So all this hierarchy comes under the ancestors. These are all ancestors. B2, A, and body. These three are comes under the ancestors. Okay, so parent, grandparent, and again another grandparent. So these are all elements comes under the ancestors. Okay. So for B1, what are the ancestors? For B1. Let's say for B1, I'm taking what is what are the ancestors of B1? B1. Can anyone tell me? Yes. A and body. So these two are the ancestors of B1. Okay, now let's say R1 I'm taking. What are the ancestors of R1? R1. Q1, O1, X2, B1, A, and body. So these are all ancestors of R1. So ancestors are nothing but the parent and grandparent and all other above nodes come into picture. They all comes under the ancestors. So in this particular context, if you want to locate any of these ancestor nodes from the self node, you can locate. Suppose I don't have any attributes for the B2 or A, still you can locate those elements by using Y2 element. If I write XPath for Y2 element, from there we can use ancestor option to locate the ancestor elements. This is bottom to top approach. You can see that. First, we are identifying the bottom element and then we are going to locate the top elements. This is ancestor. So parent, including parent also. Parent and grandparent and all other grandparents. So all this comes under the ancestor element. Next one, descendant. ancestor and descendant. So descendant is nothing but what? The childs and grandchilds all are comes under the descendant. So what is the difference between ancestor and descendant? Ancestor means the parent and grandparents comes under ancestors. Descendant is nothing but what? The childs and grandchilds, opposite. Let's say B2 is my element. From there, we can locate Y2, Y1, Y3. So these three are the child elements. Again, Y1, Y3 don't have any childs. But again, Y2 is having two childs. Even these also comes under the descendants. But again, M1 comes under the 9.1 and N1 and N2. M2 also having L1. So whatever the child from B2, whatever the child elements are comes under, these are all comes under the descendant element. These are all comes under the descendant elements. Not only childs, okay, child of childs, grandchildren also comes under the descendant. So for B2, these are all elements comes under the descendant. Okay. Now the next one, following. Following is nothing but what? For example, let's say take this B2 element. So for B2 element, B3 and B4 are called as a siblings. Means what? These three elements are having same parent. So for B2, what is a parent? A is a parent. For B3, B4 also same parent is there. So the following is nothing but what? The sibling element like B3 and B4. Along with this, whatever the child elements are there for these siblings, they are also comes under the following. Following means this part. Following means this part. So for B2, what are other siblings are there? Like B3 and B4 are the siblings. So for B3, B4, again, childs also come into picture. This is called following elements. And there is another one, following sibling. There are two things come into picture. Following elements are different. Following sibling elements are different. For example, say following means what? The siblings plus the childs of their siblings will come into picture. But when I say following sibling, this is only following. Following means siblings plus childs, the child of the sibling elements. Following sibling is nothing but what? Following siblings means nothing but what? It will get you only siblings. Following siblings, but they won't get the child elements. Okay, this is the difference. What is the difference between following sibling? Following is nothing but it will get the siblings along with the childs of the siblings. That is a following node. Only following sibling is nothing but what? Only siblings you will get. B3 and B4 you will get. You won't get the Z1 and Z2. That's called following sibling. So the next one is following sibling. This is the one. For B2, B3, B4 are the following siblings. Okay, you understand the difference? Following and following sibling. Following is nothing but you will get a sibling B3, B2, B3 and B4. You won't get the B1 again. So after following means what? B3, B4. Preceding is nothing but B1. So whatever elements are in the left side, they are all called B1. B1 is there, right? So that's called preceding element. And following elements is B3, B4. So if I say following, you will get a B3, B4 along with their child elements. Following sibling is nothing but you will get a sibling elements along with their only sibling elements. They don't get the child element. Z1, Z2 don't comes under following sibling. So following sibling. Similarly, we also have a preceding sibling. So preceding means what? This side. For B2, B1 is a preceding. Again, B1 is also having same parent. For B2, before that, whatever element is there, that's called preceding. B1 is a preceding and their children also we will able to capture. These are all preceding elements. For B2, B1 is a preceding element and whatever childs are there for B1, these elements also we will be able to capture by using preceding. Now, what is preceding sibling? When I say preceding sibling, what are the nodes you will get? You should tell me. Preceding sibling. Only you will get a B1. Okay, this is the only B1 you won't get the child elements again. See, X1, X2, X3 are the child elements of B1. So when I say preceding sibling, there is only one sibling we have, that is B1. One preceding sibling we have. But here the following siblings are there are two following siblings. B3 or B4 are the following siblings. There are two, but here preceding sibling, there is only one. So when I say following sibling, you will get B3, B4, Z1 and Z2, child elements also. Similarly, if I say preceding sibling, you will get only B1. You will get only B1. So these are the different access are present inside the XPath. We can use them along with the XPath. Parent, child, ancestor, descendant, following, preceding, following sibling, and preceding sibling. Okay. So by using this XPath access, we can navigate from top to bottom, bottom to top, in whichever direction you want, according to your requirement or XPath, you can navigate them. Okay, so everybody's understood the four important things. So now I'll show you the practical demo, how we can use them in our application practical. So these are all XPath access. So what is the use of this XPath access? We can locate any element by taking help of the neighboring element. Okay. Now let us see the practical. So to demonstrate this, I'm taking this particular site. So the table, this is contains a table actually. Go to this page. And here, this is a table. I have some example table. You can take any table to demonstrate this because it is simpler to identify all kinds of nodes, parent, child, sibling, and all of them. You can use this for normal web elements also. So this is our table. So let us try to capture some data from this table. And also parallelly, we will try to use XPath access on this particular table. Okay. So basically, if I look at this table, inspect this particular table, and the table is representing with the table tag. And there is ID is available for the table, which is customers. And if I look at this table, do we have any attributes for these tags? For example, TR is there is no attribute. For TH also, there is no attribute. So for TD is also, there is no attribute. So TD is representing table data. TH representing table header. TR is representing table row. So if I look at this particular table, we do not have any attributes for these TR or TD or TH tags. Okay, but still we can locate that element, particular element inside the particular row or in the particular column or particular cell by writing proper XPath with relative options, XPath with XPath access. Okay, so look, let's see how we can locate these elements by writing proper XPath. So let me open Selector Hub. We'll see one by one how we can locate the element. So let me go to VS Code editor and first let us create a small file. So inside the tests, creating the new file, I'll say XPath access dot spec dot js. Okay, so inside this, sorry, it is ts. Okay, so let me import required packages, modules, import. So test, comma, expect from playwright / test. Right, so imported required module. Now I'm writing a test, simple. And the first parameter is a title of the test. So I can say XPath access demo. And the second parameter is an arrow function. And before this arrow function, we use async. Inside the arrow function, we required a page fixture, right? This is the structure of the test. Now let us implement this. First, I need to launch my page. So what we can do, await page dot go to. So launch this URL. So this is the URL I'm trying to launch. Okay, this is launching the application URL. Okay, so now I'll start with the self node. Self. So what I'm going to do is I want to locate the element by itself. Okay, the element I want to locate by itself. So for example, let's go to this page. So let's say I have something called Germany here. So I want to locate this element by itself. Normally, how we can write a normal relative XPath for this Germany. If I inspect this element and look at this relative XPath is given by the selector hub, right? We can also use, so TD is my tag name, and this is the text element, right? So we can also create our own locator here, //TD, and see 38 elements are matching. So inside this, I'm providing a text method because this Germany doesn't have any attribute. XPath 1, 2, 3, we cannot use. So TD is a tag name. We don't have any other attributes. So TD text, I'm using text method you can use. So text equal to, so text equal to, you can say Germany. So you can pass a value like this. And when you pass this element, okay, this is locating the one element. So this is straightforward direct XPath. If it is locating that element, you don't need to use self again. Here self is not needed. Okay, if you want to locate the same element using again self XPath access I want to use, then what you can do is you can say // self, you need to say self, and every XPath access keyword should followed by colon. Okay, whenever you use this XPath access locator, you need to say / after / use that keyword, XPath access keyword. It can be self or descendant or ancestor, parent, all the relative keywords we can use, followed by colon. Okay, now here we need to specify the tag name of the target element. So what is the tag name of this target element? Again, TD itself. So we can say TD. That's it. This is able to locate an element. So this is not needed actually because the actual XPath itself is able to locate element. But why unnecessary we use this? It is not needed. So if we still want to use relative XPath access, you can say self : TD. So this is a syntax. So all other XPath access also we have to use it with the same syntax. We need to say / and here the keyword which we have to use for XPath access followed by colon and the tag name of the target element. Tag name of the target element. And if you want to specify the attributes of, if there is an attribute available for this target element, you can also specify inside the bracket like this. Here we don't have any attribute. I'm just leaving with the TD. So this is a self element. So this locator is pointing with what? This particular Germany element. Now we can just go back and find that element. So what is my requirement here is select a TD element that contains the Germany. Right. So how we can locate this? Await page dot locator, and here we specify the locator. So this is a self node, right? This is just locator, so we don't need await. Just want to store in a variable. So let me create a variable. Okay, and you can give whichever name you want here. I can say Germany cell. Do we need a wait statement here before the page? No, because we are just capturing the locator and storing into element. So this element is obviously what? So locator type of element. So when I say locator, so you have to import that module. Locator, we have to import it. Okay, now you got a cell, that element. And we can apply the export, or we can extract the text from the cell. Right? Can we extract the cell? We can extract the text from the cell. This is an element, right? How to extract the text? How to extract the text? How to extract the text of this? This is the locator, not the string. Yes, in the last class we have discussed, right? Text content. We use a method called text content method. Get text content, we can extract. But here my intention is I want to verify the visibility or the text is present on the page or not. Okay, I don't want to capture the text. Instead, what I'm going to do, this text is correct or not. So this particular TD element, in the TD tag, what is the text I'm expecting? Germany should be there. Okay, the text should be Germany. So for that, we can use one assertion here. Expert, if you want to validate exact text value. Okay, so you can also use to be visible. That is also fine. But I want to check the exact text value. So then what you can say, another assertion we have. So expect, use this Germany cell. This is the element dot to have text. Okay, this is also a method available to have a text. What text you want to expect here? That you can specify. So this is the exact text we want to expect. So this is the assertion. You can also use to be visible. That is also correct. So do we need to put await here? To have text. Yes, this is also returning the promise. So we have to keep the await statement here. Okay, this is exactly, we can locate element using self keyword. As I said, again, this is optional. It's not mandatory because the XPath itself is able to locate the web element. So let's execute this code. So Playwright test, and inside this XPath access dot spec dot yes. So to have text is a method through which we can verify the text element on the web page. Okay, it was taking 30 seconds. We'll see. Okay, now it is got failed. So you can see test timeout. So 30,000 milliseconds it is waited. Almost 30 seconds it is waited, but it is not able to launching the page actually. So it is taking more time to launching the page. So let us try one more time. I think this page is giving an error. HTML underscore tables. Okay, so let's try one more time. So sometimes this page is taking more time. So let me run it once again. Clear. Run headed mode. Yeah, now it is working fine. Okay, so now you can see this is get passed. So that assertion is got passed. This is how we can use self. So now similarly, we can go with another one, parent access modifier. So this is important. So what is a parent access modifier? So we can locate this element. What is a parent again? Let's go back. Yeah, this is a parent. So first we will write an XPath for one element. From that element, we can locate the parent element. So actual target element is what here? B2 is a target element, but we won't write XPath directly for B2. We will write an XPath for Y2. And by using that element, we can locate the B2 element. B2 is a parent. Similarly, if I look at this particular page, so I want to locate, let's say Germany cell is there, right? So Germany is, let's say, is considered as a child element. So this is a one element, self element. From there, I want to locate the parent element of this Germany, parent element. Okay, so what is a parent element? If I look at DOM here, this is the Germany TD element. So what is a parent of this TD? TR is a parent, right? For this TD, TR is a parent. So here you can see the DOM structure. This is a parent. So do we have any attribute for this TR? No. But the TR contains the three values. The TR is holding three datas actually, TDs. So from Germany, I want to navigate to my parent. Okay, and now the parent contains all three values. Then I will verify them that row is contains all the values or not. So from the Germany, I want to locate the parent tag, which is a TR. Now, how to locate this? The whole TR will be located. TR means the table row will be located. So how to write the XPath access colon slash slash. So dot dot. So here parent colon colon parent colon colon. And what's the tag name of the parent? TR is a tag name of the parent. Simply say TR. Now observe one element is matching. So what is this one element? The entire row itself is one element. The row itself is a one element. So what is the parent of this Germany? The entire row is a parent. So you can say Germany parent is tr. So you can use this one to locate the entire row for the Germany. So you can say page dot locator and specify this locator. Okay, this is element. So this is the parent element. So here we don't use dot slash dot dot. So dot dot is representing the a different element. So only parent element only, but that is a different syntax. So parent colon colon tr. So this will return the parent. So that I can store in a variable. Here, what is a parent? Parent is a complete row. So I can store it's a parent row. And again, this is also another const variable I'm defining, and which is also a locator. Okay. Now assertion. So how we can put the assertion in this, the parent row. So there are three items are there in the row, right? If I look at this page, how many elements are in the first row? So this is one element, second element, third element. So I want to verify in this particular row, a particular element is present or not, I want to verify. So for example, for Germany is a child, TR is a parent. Now we have navigated to the parent. So we are here now. Inside the parent, there are three elements are there and three different text elements are there. Now I will verify one of the element. So how can we verify that there is a different assertion we have? Let's say expect parent row. Okay. Inside the parent row, I want three texts are there. In the row, three different texts are there. I want to verify some text to contain text. This is another method to contain text. So among these three texts, we can verify one of the text. So to contain text. So what is the text you want to verify? You can specify that. So from Germany, we went to the row. In this row, we can verify whichever value you want. Let's say I want to verify this value. So copy this and paste it over here. This is one assertion. You can put this assertion like this. So again, to contains text also return a promise. So definitely we should put await statement here. So this is how we can use a parent. So we can capture the parent element. On the parent, we are verifying some text present inside the parent or not. Okay. So let me run this code once again. Okay, launched my page. So the page is taking some time. We need to wait for a few seconds. So two assertions, we put self and the parent. It is still taking some time. So the page itself is like that, guys. It is trying to get elements. So taking more time to get the elements. So again, it is failed with the same reason. Let us try to run one more time. Control C. And let me run without headed mode. Sometimes the page is faster, but sometimes slow. Just run one or two times if it is failed. So every time it won't fail. Sometimes it will fail, sometimes it will pass. Just try to run one or two times. So then it will pass. Okay, so now it is get passed. All right, so here we provided some text here. So if you want to verify all the text, so you should not use this one. Contain means what? A substring. So let us try. Okay, let me just put another await statement. And this time I put some text here, but instead of that, I will also keep this one also. because these three, they are different text. So this one is different, this one is different, and Germany. Germany is also part of the same row. So I'll keep it here. Now let us try. I think this will won't match because we are verifying the basically this particular, the whole text is present, right? So this is combined text. So we don't have any value like this because this is combined now, right? So you can see it is get passed. Okay, it is still passed. Let me run one more time. So let us see the description of this method. So an element that contains a given text. So all nested elements will be considered when computing the text content of the element. So you can use regular expression for the value as well. Okay. So to contains the text, substring again contains the text. If you pass any array as an expected value, the expectations are this one. Okay. All right. Yeah, it is supporting, guys. So to contains the text supporting all the values, whatever is there in that particular element. Okay, so you can use this. All right. So contain means actually it should take only substring contains, but it is taking full string. When you try to print the value of the parent row, let me try to print what you will get. We'll see console.log, because based on the output, we have to choose the right expectation. I'm trying to print the row here. We'll see what is the value it is going to print. It is still trying to retrieve the values. Okay, so it is just a locator, guys. So it is just printed the locator, but I want to extract the text value from the locator. So how to capture the text of the locator? Yesterday we have seen a method. What is that? Dot all text contents. When to use all text contents? If you have a multiple elements is matched, then we have to use all text contents, right? Multiple elements. But currently this parent element, row element is one single web element. So if it is single web element, instead of all text contents, we use only text content. Okay. So the text content method also will return a promise. So we have to say await. Now let's try to print the values of the particular row. So inside the parent row, inside that there are again multiple DRs are there, but the parent row itself is one single web element. And this locator is matching with one web element. And I'm trying to capture the text of the TR table row. I think this will return all the 3 columns text. But how it is returning, we need to know. So we can see again, this is the same problem. Let me try to run one more time. Okay, now you can see these 3 values are returned. So all 3 values are written as a string format. So we can just provide that as a string format by combining this. So this is still working fine. Okay. All right. So this is a parent element. So we can capture the parent element using the child element. Fine. Now let's see how we can use another one, child. So we have seen self element, parent, and a child element. The next one is a child. So child element is nothing but what? Suppose whatever element we located under this locator, whatever the childs are there, these are all called child elements. Y1, Y2, Y3 are the child elements. So again, in this particular context, my requirement is I want to get TD children of the second TR in the table. So first let us go to second TR in the table. The same table, where is second TR? This is the second TR. Let me inspect that. And if I go back to the DOM structure, so the first TR, second TR, third TR, fourth and fifth TR. So totally how many TRs are there? There are so many. 1, 2, 3, 4, 5, 6 TRs are there. 7 TRs are there totally, including heading. So I want to go to second TR. So where is the second TR? This is our second TR. So this is our actual element we need to write XPath. From the second TR, I want to capture the all child elements. So how many childs are there for this TR? There are 3 childs are there. So this is TD, TD, TD. So these 3 TDs are the 3 child elements of the second TR. Okay. Now I want to write an XPath for this TR. From there, I want to access the child elements. I want to access the child elements. All child elements, not only one child. I want to access all the child elements. Now how to write an XPath? So first we'll go to second TR. So how to go to second TR? So how to navigate this? Because first directly we want to write an XPath for the TR tag because we don't have any attributes. Now how to write an XPath for this TR? So from there we will get the child elements. So to get this second TR, we need to start from the table itself. So from the table, there is ID customers. So I'm writing XPath like this. Table is my tag and I'm using ID as an attribute, ID equal to. So what is the value of the ID? Customers. I say customer. So this is actually pointing to the entire table. So inside the table, we can skip the T body because we are writing the relative XPath, which will directly jump into the elements. Now I want to extract all the TRs first. So when I say only TR here, see this, how many TRs slash TR? 7 TRs are there. So now it is getting 7 TRs. Now I want to go to second TR. There are 7 TRs are there, 7 rows are there. I want to get the second one. Then how can we capture the second one? By passing index number. Right, when I say 1, first TR it will highlight us. 2, second TR it is highlighted. So now this XPath is exactly pointing to second TR. Now by using this XPath, this is actually parent, second TR. This is matching. Now I want to extract all the child elements. So to extract the child elements, how we can extract it? Simply we can say child colon slash child colon. So what is the tag of the childs? TD. Simply say TD. Now 3 elements are matching. Okay, so 3 elements are matched. So what I am getting here? I am getting the child elements of the particular element. So we capture this element first and then from there we capture all the other child elements. So this XPath will give you 3 child elements. 3 elements. 3 childs are there, right? So we will see how we can validate that. So this time we will validate the counter. So go back to this. Now I'm writing the XPath. Page dot locator of. So this is the element I'm storing into a variable. I'll give a name called second row cells. This is second row only. We are capturing all the cells and const variable. And this is also a locator type. Right. So now what is the assertion we can put? How many childs we capture from this? 3 child elements we captured. So I want to count exactly the child 3 elements are there or not. For this element, 3 childs are there or not, I want to verify. So then I can say expect of second row cells dot, there is a method called to have count. These are all different assertions. To have count. And how many we are expecting? 3 child should be expecting. So this is another way. So to have count. Again, if you want to verify the text also, you can verify that. Okay, so again, you can use the same thing. So as soon as you get this element, you can also use the same assertion here also. But you need to provide the data. Some data should be there. Okay, so now I have captured one element here. From there, I'm capturing all child elements, and then we are finding how many child elements are present in the particular row. Let's execute one more time. Basically, we are verifying the number of child elements. Yeah, here we have, no, here we will get only, see here, child of 3 means what? How many child elements are there? 3 are there. So obviously you will get 3 child elements here. 3, yes. So 3 elements will be returned. That's the reason the count should be 3. Here we're expecting 3. So this time it is returning multiple elements. Okay, remember this. Returns. Again, it is get failed. It returns multiple elements. What are they? Multiple TDs. Okay. Execute one more time. So even this locator is returning single element or multiple elements, the return type is same locator itself, and same method we have to use. And we don't have any separate method for locating multiple elements. Same method, same return type is there, but only the depends on the XPath decided whether it is returning one element or group of web elements. Now it is get passed. So exactly the count is 3. Okay. Right. So this is a child access, child elements. Now the next one is ancestor. So ancestor is nothing but what? The parent and grandparents. It will parent and also grandparents. So here await is required for expect. Await. Yes, it is returning the promise also. So let us try to keep await also. Okay, now it is get passed. So now let's move on to this ancestor. So ancestor means what? The parent and grandparents. Parent and all other grandparents also come into picture. That is ancestor. Now let us see one requirement for ancestor. So let us say get ancestor table of the Germany cell. So if I look at the same page, so I can go back to the Germany. So this is my cell. And if I again inspect this TD element, for this TD, what is a parent? The TR is a parent. So again for this TR, what is a parent? For this TR, what is a parent? T body is a parent. For T bodies, what is a parent? Table is a parent. So from this Germany, from this particular Germany, I want to get all the ancestor tags. Okay, there are multiple ancestors are there. So for Germany, what is an ancestor? TR is an ancestor. For this again, T body is an ancestor. So T body, table, these are all ancestor elements. So let me write an XPath like this. Here, go to selector hub. I'm writing an XPath for this. First, write an XPath for Germany. So how to write XPath for Germany here? I'm just directly writing //td is my tag name. And I'm using text. So text equal to, so I say Germany. So this is exactly matching with one element, Germany. Now from this element, I want to extract all ancestor elements. So to extract ancestor element, I say hash ancestor : when I say star here, for example, I'm not specifying any target, simply say star. It will return all ancestor elements for this Germany. So Germany, TR is an ancestor, T body is an ancestor, table is ancestor. Again for table, div is also an ancestor. So whatever ancestors tags are there, all the tags will be counted. So totally 12 elements are matching. Star means representing all the tags. But I want to get a specific element, specific ancestor, right? So for example, I can get this tr. It won't have any value for this. We can ignore this. And for this tr, what is the ancestor? Again, t body is also ancestor. Table is also ancestor. Now I want to capture this table. I want to capture what is the table? Table is an ancestor for this Germany. So I want to capture specific element. What is the specific element here? Is table is a specific element. So here you can specify the target element. So target element is what? Table. So you can say table. Target element, I'm writing a table. Now one element is matching. The whole table itself is considered as a one element this time. So I'm getting the ancestor element table. Similarly, whichever ancestor you want to get, you can specify the tag name. Specific ancestor, if you want to capture, you can say the tag name of the particular ancestor element. And if you say star, it will return all ancestor elements. Now I say table here. So it will return only table element. So capture this and write an element. Page dot locator. And this is returning the whole table element. And that I'm going to store in a const variable. Let's say table. This is also locator. Will it return single web element or multiple web elements? Single web element. The table itself is representing one tag. So one single web element. So now I want to put some other different type of assertion. So what assertion we can put on this table? Okay, so table is anyway it is visible, and I want to verify some attribute. Okay, so for example, what are the attributes are there for this table? We have a class attribute, we have ID attribute, we have XPath. So I want to verify the attribute ID attribute is present or not. ID attribute is customer or not. I want to verify for this particular table. So the attributes level also we can put the assertion. So I'll put some assertion here. Await, expect, and take this table dot to have attribute. To have attribute. So this will take two parameters, guys. Okay, one parameter is what is an attribute we want to verify for this table. I'm verifying the ID. So specify the ID, comma, what is the value you're expecting for that ID? Customers. This is the value I'm expecting from the ID. This is simple assertion we can put. So we can also do validations on the attribute level. So the particular attribute value is correct or not, we can verify. So I'm verifying that for the table, which is ancestor element, which is an ancestor element. Okay, let's go and execute. Perfect. So it is get passed. So this is called ancestor. The next one is descendant. So descendant is nothing but what? Childs and grandchildren. Child elements and also grandchildren elements. So every hierarchy you will get child and grandchildren you will get in descendant. Now my requirement here is get all TD elements under the table. If I go back to the table, so where is a table tag? Here is a table. So now the table is a self element. From here we are going to start. Inside the table, whatever the tags are there, TD, TR, in everything, all these tags are comes under what? Descendant elements. Children and grandchildren, everything. So these all TRs are what? Direct children of the table. So T body itself is one children. Inside the T body, these all TR tags are again children. And again, if you expand every TR, there are grandchildren. So descendant is nothing but what? We can capture all the elements under that particular element. So let me take table as a self element. So I'm writing XPath / table and at the rate ID equal to customer. So this is the actual table element. And now I want to get all descendant elements of this table. So I can say / descendant. So / descendant colon table slash descendant colon. When I say star, matching with all descendant elements. So 29 elements are matching. 29 elements are matching. But I want to capture only TD tags. Only data I want to capture from the table. Only data I want to capture from the table. So then I can say only TD tag. Then 18 elements are there. So exactly it is 18 cells are matching. So when I write this XPath, how many elements are matching? 18 elements are matching. How many elements are returning? 18 elements are returning. So now I'm using this XPath. So what exactly we are doing? We are identifying some self element. From there, we are capturing the descendant elements which are having TD tag. All descendant elements are having TD tag. If I don't specify TD tag instead of TD with a star, it is matching with all, even TR, TDs, everything. But I want to specifically say TD tags. So only 18 elements are matching. This is descendant elements. These are descendant elements. Page dot locator. And this is also returning descendant element. I can say all TDs. This is also locator type and variable type is constant. Right. So now I will put some value. So basically this is having a group of elements. 18 TDs were captured. So can we verify the count exactly? Yes. So await expect all TDs. I want to verify the count. So what is the method we have to verify the count? So earlier we have already seen to have count. To have count. So here we can say 80. Okay, so this is how we can verify, we can capture all descendant elements of the particular element. Execute now. So this is a descendant access. Means what? It will capture the child elements and grandchildren elements. All children and grandchildren elements will be captured by descendant. This is exactly opposite of the ancestor. So ancestor means parent and grandparents. Descendant means children and grandchildren. Okay, now it is get passed. So this is descendant access. Descendant, how we can use a descendant. So next one, following. Following means what? Same thing. B2, B3, B4 are the siblings actually. Siblings along with the children of the siblings. Siblings along with the children of the siblings also you will get in the following node. Okay, now let me write a requirement. Siblings and children of the siblings. So now get TD that comes after January in a document order. For example, let's say, let me remove this. So in this page, you can see Germany. So this is a Germany element. So after the Germany, whatever the elements are there, following elements, I want to capture. So for example, let's say this is the element of the XPath. So from this element, this is the Germany. Do we have any siblings for this Germany? Sibling elements. Sibling is nothing but what? Again, if I go back and see following. So for A, B2 is a child element. B3, B4. So these two are the following elements. Again, B3, B4 is also having same parent element. B3, B4 is also having same parent. Now, if I look at this HTML and DOM, I'm locating this Germany. And after the Germany, whatever TD is coming to picture that I want to locate. So do we have any sibling for this Germany? Sibling. Do we have any sibling? So let me just try colon slash slash following slash 742 elements are matching. So I'm starting from this Germany actually. So from this, the rest of all the nodes. So like all these nodes are comes under the following. All these nodes are comes under the following, but I want to get only TDs. I don't want to get all the followings. I want to get only TDs inside the following. So I can use TD tag here. So 35 elements are there. So 35 elements are exactly matching. This is a following element. Following, just a following. It's not following sibling. It is just a following. Okay, suppose if I say following sibling, colon, colon, instead of following, is a following sibling. So then 0 element. Why 0? Because we don't have a siblings there actually. So for this journey, do we have a sibling? There is no sibling. So that's the reason it is giving 0 as a sibling. 0 element is matching. But the following elements are there. Following elements are nothing but these are all following elements. For this Germany, what is the parent is TR. Again, TR is part of the T body. So for this Germany, these are all inside every TR. There are some values. So after the Germany, whatever values come here, these are all matching with the following, only following. But when I say following sibling of TD, we don't have any sibling for that. Okay, so this is a following and following sibling. So let me use this here. Page dot locator. I'm just choosing only following and capture the TD tags. So will it return single web element or multiple elements? Multiple elements. This is returning multiple returns. Const following cell of locator. Okay. So now we can verify something here. The following cell, the values we can verify. And again, when I say only TD, what I'll do is go back here because it is returning multiple web elements, 35 elements, and I want to extract a specific element. For example, get the TD that comes after Germany. So whatever TD comes after Germany that I want to capture. So this I want to capture. This is the next TD, right? So I say TD of first element. One element is matching. So this is returning. So now I'm using this XPath. Following one element. Capturing the one element which is following by the Germany. So now this time it is returning one element in this. Now I can verify the text of that element. So await expect of following cell dot to have. So how we can verify the text? To have text of what is the text we are expecting here is this one. This is a text. And also directly I will write following sibling also, the next one. Same thing, but I want to get all the TDs to the right of the Germany siblings. So what are the siblings are there for this Germany? Do we have any siblings for this Germany? Germany, do we have any siblings for this? There are no siblings, right? So it will return 0. So I will write the same XPath again. Germany, instead of following, I will say following sibling. Following sibling of TD. So 1 is not needed. So I'm just getting all the siblings, but as of now, this will return 0 only. So this is the following cells. This is, I will name it as a right siblings. Okay, now we'll see how many are there. So what is an expectation? Await page of, yeah, now tell me how to verify the number. Dot to have count. So 0 is there, so it should return 0. So following and following sibling. So now it is running. Okay, now it is still running. Okay, so it is failed because of timeout. Let's run one more time. No, count is 0 only, right? So siblings, there are no siblings actually. So 0 siblings. If the siblings are 0, if this element is not matching with any element, it won't return anything actually. So that locator method return anything, not, it will just return uh, something called as a null, because 0 element will be returned. If the XPath is matching with element, one single element, then return that element. If the XPath is matching with multiple elements, then multiple elements will be returned. If the XPath is not matching with element, it won't return any exception. It will simply return 0. Okay. So currently there are no following sibling elements. So obviously return 0. So the count is obviously 0. So that's the reason the expectation is got passed. So can we have one with the following sibling example? Following sibling. Okay. So let me take another one. So for example, let's say take this one. Following sibling. Let me take this one. So for this, there is a sibling. So for this element, Germany is a sibling, right? So let me write this one. So what is the value of this? Maria Anders. So instead of Germany, I'm just giving this. So from this element, I'm capturing the following sibling and count I'm verifying. So we'll see what is the count. We don't know. Count is only 1 currently, right? So if I look at back here, for this element, this is the element. I look at this. So for this element, how many following siblings are there? Only one is there. So which is Germany. So let's keep it as 1. Now execute. Okay, so now it is get passed. So if you have one element will be returned. If you have multiple elements, then multiple element returns. If it is not matching with any of the element, then it will return null. So there is no value. So we can verify with a 0, right? So this is how. Next one, we'll go back to the preceding and preceding sibling. Preceding and then preceding sibling. So let me take next one. Preceding access. Get to TD just before Germany. Get to DD just before Germany, which is actually the preceding element. Preceding means what? This is the one. These are all preceding elements. If I go back to the Germany again, so do have this preceding. So these are all preceding elements. So whatever the comes Germany, so before that, whatever we have, these are all preceding elements. So let's capture the preceding element. So here I'm using Germany. First, we'll go to Germany text. Okay. Now slash preceding colon SS*. These many elements are matching. Preceding means before that element, whatever element comes into picture, they're all preceding. but I want to get preceding sibling. So do we have a preceding sibling for this element? Preceding sibling. Let's see. Preceding hyphen sibling. Two elements are matching. So these two are the preceding siblings of Germany. You can see for the Germany, this is one preceding sibling. This is another preceding sibling. These two are the preceding siblings of the journal. So let me try to use this. So what is the requirement here is I want to capture TD just before Germany. So I'll just say only TD here. So two elements are matching. These are preceding elements. And go back and write the locator. And again, I want to get just before. So what is my requirement? Get the TD just before Germany. But there are two elements are matching. I want to get only just before means this one. You can say one. One element is matching. So this is a preceding element. Page dot locator preceding element. And that I can store in a variable as a const. So preceding cell. This is again locator type. Now, so we can verify the text in this cell because it's returning one single web element. So await expect preceding cell dot to have text. So to have text, and what is the text we are expecting is this is a one, right? So this is how we can use preceding. And same thing, preceding sibling. Another requirement also I will directly write. So preceding sibling. So get TDs to the left of January. So left, so same requirement, but here we're capturing just before TD. And here we're returning all the TDs left of January. So preceding sibling, because it is filtered actually. Only siblings you will get. Same requirement, but only siblings you will get. So Germany preceding siblings. And preceding sibling of, I say only TD. So let's try this XPath. And two elements are matching. And again, among these two elements I want to capture. So both TD1 and TD2. So how many elements are returning this? Two elements are returning actually. So here I'll say left siblings. And now I want to verify something here. First, I can verify the count because it is returning multiple elements. I say dot to have count is one method. How many elements are returning? Two elements are returning. Again, among with the number of elements, I want to verify the text of those elements also. Text of the each element I want to verify. So currently the left siblings, this variable is having two elements, but I want to verify the text of two elements separately. Then how can you capture? So how to capture the first element from this? In the last class, I have told you one method. First element, last element, nth element. We have a methods, right? So I can put one more as expectation here. Expect from this left siblings, I want to get the first sibling. Dot first you can use, or you can use last, or you can use nth. I'm using nth sibling of 0. Index will start from 0. Dot to have text. So what is the text I'm expecting here is this is the one. This is a 0 text, first one, and keep it here. And same thing, another expectation for second element, nth of 1. So what is an element we are expecting? This one. So individually, if you want to verify, you can do that. So these are the two more assertions additionally added on this sibling. So this is preceding and preceding sibling. Let's go and execute. I think we haven't put a wait. A wait is needed here and also here. So these are all different XPath axes, guys. So you can navigate throughout the DOM in whichever direction you want or whichever element you want to locate. You can use XPath axis. And if I look at all these combinations, we never written XPath directly for the target element. Okay, now some expectation is got failed. Expected string is this one, but received string is this one. Okay, E is missing actually. Yeah, E is extra. All right. So this is how we can use all XPath access, guys, and very important. And whichever direction you want to navigate on the DOM, so you can still use this XPath access. And if I look at all these combinations, we haven't written the direct XPath for the target element. For example, in this XPath, what is the target element? This is the target element. But we located this element by using another XPath, another element. Similarly, if I go back to the child elements or any other elements, these are the target elements. But we have not written XPath directly for the target elements. Instead, we written XPath for the neighboring node. Whichever node is neighbor, it can be child or parent or ancestor, sibling, whatever. And from that, we actually find out the actual element. Okay. So this is helpful whenever you don't have the attributes for the elements. But if the attribute is available, for example, table, for the table, attributes are already available like this. So you can directly go and look at the element. If I look at the first one, self element. So in this context, we don't need any self because we directly attribute is available. We can capture that element. But sometimes if you don't have any attribute for the element, then you can locate the nearby element. And from that, you can navigate to the actual target element. So for this, you can use this XPath relative locators. So I have given all the examples in the same document. You can just go through one by one and just do one round of practice. That is enough. And this is very, very slow, guys. So when I use relative XPath, execution becomes very, very slow. And XPath itself is very slow. But if I add this relative, or if I add this XPath access, again, it becomes very much slow. So that's the reason we don't prefer to use this. And sometimes if you find a web page is very complex, and if you don't find any attribute for the elements, in very rare cases, you can go with XPath access. Okay. So what is the main difference between CSS and XPath? In XPath, we can traverse from top to bottom. We cannot go reverse direction. But in XPath, we can go from top, we can traverse from top to bottom and bottom to top. So in whichever direction you want, you can navigate or you can traverse in the DOM. So that is a major difference, right? So we'll stop here for today's class and just do one round of practice. In the next class, we will continue with the rest of the topics. All right. So we'll stop here.